our video on related rates. So, when we do our equations, so there's a bunch of stuff on your notes that you can read. Okay, so I prefer to kind of go through the problem, and you can go back and see which of these things that are listed on the notes, like the make a sketch and yada yada yada. Like if you feel like you need to have a procedure that's very step by step, then you have it. Okay, so we're just going to go through the examples, and then you can go back and note those things. So starting here with example 1. So this is a non-real example. So this is just an example that says here we have these things, okay? So they're just giving you an XY equation and then asking you to find some steps. So we won't have units or anything on this one, and then the rest of the problems are all application problems. Right? So for this one, we start off with y equals x squared minus 3x, and they tell us to find dy dt when x equals 3, given that dx dt is 2 when x is 3. So when we do these problems, we're going to always have a place where we want to find these answers, but we cannot plug that in until we're done with the derivative. Because what would happen if I plugged in 3 right now? I wouldn't have anything because I would have a constant, and then if I did the derivative, I'd have 0. So I can't plug anything in. So all numbers and constants plug in later. Okay, so you have to do the derivative first, and we're doing it with respect to t, and we know that because it asks for dy dt. Okay, so we're going to do the derivative left to right. So the left is going to be dy dt equals, and on the right, what will we have? Right. So we have to remember that the variable that's inside is not t, so there's always the chain rule. Now that I have all of that, I just need to evaluate it for what they gave me. Okay, so they gave me information. So you can do a lot of different things. I like to just write when x equals 3, and then plug everything in. So dy dt is the thing I'm trying to solve for, so I just leave dy dt. And then I have 2 times x, which is 3, times dx dt, which was given as 2, minus 3 times dx dt, which is the 2. So my answer is 6. And I don't have any units here, so we don't write any units. It really should be some kind of measurement unit over time, but we didn't have anything. So that was just an example of the process. Okay. So now let's look at this. So all of these have this no, given, and find. And you can either really write those words down, but I'll probably stop using those words in a little bit and just kind of write stuff to the left and not worry. But it's kind of what you want to do. You want to go through every problem, and you want to write down anything that you know, anything that was given, like a value or a rate, and then what am I trying to find? Okay, we always want to write that. So first time you read a problem, always read it really fast. Don't really pay a lot of attention, just get the gist of what are they talking about. So it says a pebble dropped in a pond, causing ripples. Radius of the ripples increasing at this rate. What's the radius of, when the radius is 4, what rate is the total area of the disturbed water changing? Okay, so I just run through it. Then I go back and say, okay, so they're talking about a pebble in a watering circle. So let's go back and read it again. A pebble is dropped into a calm pond, causing ripples in the form of concentric circles. Concentric meaning, so right, inside, so same center. Yeah. They have the same center. That's what concentric circles mean. So the radius r of the outer ripple is increasing at a rate of, so therefore what was given to me is dr dt, because they told me the rate of change of the radius over time is a constant rate of 1 foot per second. So there's my given information. Okay? And then it says when the radius is 4 feet, so we're trying to find at what rate is the total area of the disturbed water changing. So we're trying to find dA dt, area, how much is it changing, when r equals 4. Because the rate of change will be different at all the different places, but this is what it will be we want to find out when r is 4 what the rate of change is. So then know means, okay, what equation do I know from geometry or any other math class? What formula do I need in order to relate these things? Area. So area equals pi r squared. So always write down a formula that you know that has something to do with the variables that were given. Write down any rates of change they give you and any rate that you're trying to find. Okay? And so then what we're going to do is write the equation. So we have the equation for area equals pi r squared, and now we need to do the derivative with respect to time. So we get dA dt equals 2 pi r times dr dt, because again we have pi is a constant, so 2 times r is that derivative, but r is not t, so it's dr dt. Okay? Now I want to find the answer when r is 4. Now you can write it a couple of different ways. So we can also write it like this, dA dt, and then evaluate it at r equals 4. That's another way to write it. Or you can just say when r is 4. Either, it doesn't matter. The key is you have to say you're doing something different. So it's not the same. So I simply plug in. So I have 2 pi times 4 times dr dt, which is 1. So then I just get 8 pi, and then we need units. It'd be feet squared per second, right? Because we have dA dt, so we have area units over the time units that we have. Okay? Okay, let's go to the next one. So now we have air being pumped into a spherical balloon at the rate of 4.5 cubic feet per minute. So I'm going to go ahead and write that as a given. dV dt. Oh, is it different? Oh, it's different, isn't it? Okay, let me change that to match your worksheet. So this is 800, and it's cubic centimeters instead of feet.
Yeah.
Okay, per minute, find the rate of change when the radius is 30 centimeters. Okay, that should match. Okay, so air is being pumped in at this rate of cubic centimeters per minute, which tells you it's volume over time, right? So that's dV dt. So dV dt equals, and then centimeters cubed, right? And then find the rate of change of the radius. So this is what we're trying to find. So that's dr dt, rate of change of radius, dr dt, when the radius. So we can also do evaluated at r equals 30 centimeters. And then, so what kind of equation would we want to write? Yeah, and now the volume of a sphere is probably one of those we don't remember. Luckily on the AP test, they actually usually give you those formulas, but don't forget you have it in your composition book. I would still put a little star by it. It came up. I probably should review it. So anytime anything comes up, if you didn't know it and you had to look it up, make sure you put a little asterisk by it or a little star so that you know, hey, it actually came up, I need to know it. So that, do you remember the formula? No, this is a sphere.
Oh.
It's 4/3 pi r cubed. The only thing that changes is the radius. The radius determines the whole thing because it's not raised in height. So you're thinking of a cylinder or a cone. Alright, so volume is 4/3 pi r cubed. So that's all the stuff I need. So now I'm going to write that down, 4/3 pi r cubed. And then I know that I need to do the derivative because I need to find dV or dr dt. So dV dt will equal, when you do 3 times 4/3, the 3's will cancel, so make sure you pay attention to that. So it'd be 4 pi r squared drdt. Now, perfect example here. Do not solve this for drdt, even though that's what I'm doing. Go ahead and plug all the numbers in now, and then get drdt by itself. Less algebra, less extra work. So dv dt was 800 4 pi times, what r are we using? So 30 squared times dr dt. And then we're going to try really hard to not use calculators very often, okay? Because we're going to try our best to always write the exact answer down, and then if you want to, you can always write exact, squiggly equals, and then put it in the calculator. But there's too many times that we are going to need to match without the calculator that we need to practice, okay? So we're going to do this. We can do it. It's 800 equals, so 30 squared would be, so I have 900 times 4 pi. drdt probably could have gone directly to this next one, which is 800 equals 3600 pi drdt. So how will I get drdt by itself? Right, so we just divide by 3600 pi. The zeros will cancel. 8 and 36 has a 4 in common, so it's going to be, yeah. Right, and then my final answer, I need to write drdt equals 2 over 9 pi, and then my units. So since drdt ended up on the right, if I didn't switch it earlier, then I need to switch it now so I can have the units. So what would our units be? It's radius. Right, just centimeters over minutes because it was cubed for volume and radius is a single. And that's it. Alright. So, next question. So we have the top of a 25-foot ladder sliding down a wall at a constant rate of 3 feet per minute. The vertical changes. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So here's an example of one that I definitely would want to draw something to get an idea of what the situation is. So I usually do you know how we always do our scratch work to the right. So I would actually not do this no given find, which I can't get rid of because they're stuck to that, but I'm going to ignore them, so you can kind of ignore them. So I always draw my picture to the right, and then I write all the given and everything under it and beside it and whatever, okay? So you have a wall, and you have a ladder leaning against the wall, and assuming that the building is like it's supposed to be, that will be a right triangle. Now, there are some numbers in here, but the only thing that's actually constant is the length of the ladder. So it is actually 25 feet, the length of that ladder. But the two lengths of this triangle, which one of them represents, so the ladder is sliding down the wall, or up, sliding down the wall, right? So that means this is going down, and this one's going out, right? As the ladder would slide down the wall. This distance is getting smaller, and that one's getting bigger. Now, if I do things like this, I always make X the horizontal change and Y the vertical change, because we don't want to make it more complicated and not do that, okay? So there's my picture. Now they tell me that the top of the ladder is sliding down the wall at 3 feet per minute. So which variable represents down the wall, or represents going up and down? Okay, so that means that we're going to say that what we know is that dy dt equals it's sliding down the wall, so -3, good, and then it's feet over minutes. And then we also know dx dt, or no, we don't know dx dt, this is what we don't know, right? Distance of the ladder to the wall, so dx dt equals question mark when, what is the information, when do we want to know when it's happening? Okay, so when y equals 7, because y is the distance from the ground to the top of the ladder. So that's how I like to organize. There's all that stuff, okay? And then you can skip the no given find because we really just wrote it all in one spot, okay? Now what we need to do is write an equation that relates those things. So what do I have? I have the sides of a right triangle. So what equation would make the most sense? Right, so Pythagorean theorem, so that would be x squared plus y squared equals 25 squared. There's my equation. Notice I cannot plug anything in for x and y yet. 25 can be a constant because the ladder is 25 feet long. It's not going to change. How far it is above the ground and how far away from the wall is going to change. Okay, so they have to stay different. So now I do the derivative. So I'm going to get 2x dx dt plus 2y dy dt equals, nope, but it doesn't matter because I'm doing the derivative, so it's 0. There you go. So even though we might think, oh, I need to do that, well, I may in a minute, but I don't need to right now. Okay, so now my problem is I know that we're doing this when y is 7, and I know dy dt, and I'm solving for dx dt, but that leaves out x. But I can find that for that specific situation, the ladder again is 25, y is 7, and x is what I need to find at that moment. Now, if you don't know this, this is one of those Pythagorean triples. It's a 7, 24, 25. If you didn't know that, you'd have to do the Pythagorean theorem and figure it out. It just happens to be 1. So at this moment, okay, so at that moment, that's the values, because it's changing, the ladder's moving, but right then, that's what we get. So now all we have to do is plug everything in. So we have 2 times 24 times dx dt, that's the thing I don't know, so just leave it in there. And then 2y, so that's 2 times 7 times dy dt, which is -3, and then that's going to equal 0. And so now I'm going to solve for dx dt. So I'm going to have 48 dx dt equals, well, this is negative 21 times 2, negative 42. Move it over, right, positive 42, good. And then, so that gives me dx dt equals 42 over 48, which would be, what do they have in common? 6, so it would be 7 over 8, and then my units are feet per minute. And then, like I said, you can always put these in the calculator, and if the answers are decimals, then of course you would just have done that from the beginning. But here's what's nice. So again, even though I could have multiplied stuff out and solved, I could have solved algebraically from the beginning, better just to plug the numbers in, and then much easier just to get all that dealt with. Okay, so try not to do a bunch of algebra if I know I'm plugging stuff in. Okay, so now here's one that'll take just a little bit more to set up. So we have, we'll just have to draw this. So we have at noon, ship A is 150 kilometers east of ship B. Ship A is sailing west. Ship B is sailing north. How fast is the distance between the ships changing at 4 o'clock? Okay, so basically now I need to think, okay, I've got some ships, and I have to think about how they are in relation to each other and how I could draw a picture here. So ship A is going west and ship B is going north. So if I think about the starting time as being right here where this right triangle goes, if I'm going west, I have ship A right here going west, which would be this way to the left, and ship B is going north, so that puts ship B here, right? And then how fast is the distance between them changing? So the distance between them is this, which we can use D, but often we use something else. So if I'm going to use X and Y again because of the vertical and horizontal, I'm going to use Z here. But I could use C. I don't usually use D because then you'd have to do DDT, which is, yeah. So we usually don't use distance, but you can. It just looks a little bit weird. And so then we got to think about all the steps. So that's kind of the picture, the idea. So now we have to figure out what's going on. So what was given? So we were given that dx dt, which is ship A. So we have dx dt is 35 kilometers per hour. And ship B is driving, whatever, sailing at 25 kilometers per hour. And then what we want to know is dz dt. That's what we're trying to find. So dz dt equals question mark when time equals 4 hours. Okay? So this one's a little different where we have to think about all of that stuff because we know what's going on a little bit, but we've got to figure out how to write that. Okay. So we need an equation. So we know that x squared plus y squared equals z squared. I mean, we know that's going to be Pythagorean theorem, right triangle, we got sides. But that's too many variables. So one of them needs to go away. So we need to figure out how one of them can go away. So do we know anything about any of these? Well, we know ship A is 150 kilometers east of ship B, which means that that's why I wrote it to the right, because it's east. It's moving west, but it's 150 kilometers to the east. So what does that mean? Is there an expression we can write then? So we need to figure out if we can write an expression that gets rid of one of these variables. So if we think about kind of about the x and y. So if you think about the direction for ship A, would this be 150 minus x that we would actually want to say? In other words, it started out 150 away. It's not really x away from it because it's going back towards. In other words, the original place that it started was 150 miles away, and it's moving x back west. So its actual distance is 150 minus x that we would have in the expression. So we have to be a little bit careful. It's not actually x squared plus y squared equals z squared. It's actually 150 minus x squared. Okay, so we're going to kind of change this. I'm just going to scribble that out and write 150 minus x whole thing squared plus y squared equals z squared. Now, here's how we kind of know whether we have too many variables or we're good. Can we figure out x and y based on the fact that we're going to do this when there's a certain value, when t is 4 hours? So if something's traveled for 4 hours at a certain rate of speed, I know how far it's actually traveled. So I can actually find the values of x and y at that moment. Okay? And then z is what I'm trying to find, dz dt. So we're good to leave z in there, and we have values for dx dt and dy dt. Okay, so we should be good to leave all these variables in here. because we can figure out something for all of them. But let's say I wasn't sure, I can just do the derivative. And then if I have no way to substitute something, then I'm like, well, maybe I have to get rid of one of those variables before I do the derivative, okay? So the key here is recognizing that 150 minus x is a little different than the distance being x. We could probably say it's x, but that's going to be a little confusing when you think about its distance, how much it's gone in 4 hours. So let's just do the derivative and figure all this out. So we're going to use the chain rule on the first one. So we're going to have 2 times 150 minus x to the first times the derivative of the inside, which is -1. So I'm going to put the negative there with the 2. Times, well, be careful, dx dt, because the inside was not t. So we have to always remember that. That's the key here. Then plus 2y dy dt equals 2z dz dt. Okay, I'm going to kind of box in my little scratch area over there anyway. Okay, so now what do we need to know? Well, we need to know what x, we've got dx dt and dy dt, they told us that. But we need to figure out x, y, and z at the moment time is 4. Well, how are we going to figure that out? Well, again, it's going 35 kilometers per hour for 4 hours, and it's going 25 kilometers per hour for 4 hours. And then I would just use the Pythagorean theorem to figure out z at that moment, the actual distance. And then what I'm trying to figure out is what rate is it changing at, okay? So I'm going to move down kind of below this scratch work that I did and have more scratch work. So when t equals 4, you know that we're going to have x equals 4 times 35, which is 140. And we're going to have y equaling 4 times 25, which is 100. So Pythagorean theorem, z would be the square root of x squared, well, 150 minus 140 squared plus y squared, if you think about your picture. So in our picture, remember, this is really 150 minus x. So we know that it's gone 140 miles, which means it's only 10 here. 10 squared plus 100 squared is going to equal z squared. So z will be the square root of the 10 squared plus 100 squared. Which is going to be, and I'm just going to give you this, it's 10 square root of 101, but this would probably be a calculator problem. You can get a decimal for that. Or you can do it in your calculator and get a radical, or you could literally just write it square root of 100, or 10,100. It'd be fine, okay? That's what you're going to get. So now all I do is plug everything into the situation. So I'm going to have -2 times 10, because it's 150 minus x, and x is 140, because it's gone 140, times dx dt, which was 35. Okay, and then plus 2 times y, which is 100, times dy dt, which is 25, equals 2 times z, which is 2 times this 10 square root of 101, times dz dt. And I don't have a lot of room here, so I didn't write this out very well. So I need to make my paper wider, but I already did it, so I'm going to leave it. So that's, again, plug everything in. So just the main thing here is to make sure that it makes sense that we can't really call this distance x, because we know they were 150 miles. X is how much you're going in this direction. So obviously when we have gone for 4 hours, the distance is now over here somewhere, because it's it's more in there because it's not very far east of where it was originally, and then that one just went further north. So it's going to be like a little skinny triangle. Okay. So now all we do is just solve for this, so do a bunch of arithmetic. So I'm going to end up not keeping my equal signs lined up, obviously. So I have negative 350 plus 2,500. Or no, that would be not 2,500. That'd be what was y? Wasn't y 100? Yeah, so this would be 5,000, right? Yeah, equals that 10 square root of 101 dz dt. And guess what? Free response question on the AP test, you could even write this answer down. You could even actually write, you could leave it as negative 2 times 10 times 35 plus 2 times 100 times 25 all over square root of 10,100. And that would be fine. Now in real life, I would probably want to figure out what that number is and get a decimal so that it makes sense. But if this is the free response test, you can leave it like that. So we would say that dz dt equals however we decided to write that. Again, or use the calculator to get a decimal, and then you want your units, which would be kilometers per hour. And that's the final answer for that, okay? So at any point, it's also sometimes easier just to get dz dt on the left just as you write it, so it's easier. Okay, so let's do the next one, and we may leave the last one to do in class so that we can kind of use it for review. So we'll just do this one only. So we have a right circular cylinder. It's changing shape. The radius is decreasing at a rate of 2 inches per second, while the height is increasing at a rate of 5 inches per second. When the radius is 4 inches and the length or height is 6, how fast is volume changing? So they've given us this equation, and they gave us the volume equation, which on the AP test they often do, but again, I still would kind of write that down. So I wish I could get rid of this, but I can't. All right. I don't even think the eraser will get rid of it. No, because it's text, but all right. So I would again go ahead and draw a cylinder just to get a perspective on what's going on. So I have a cylinder. Oh, can't dash very well because it so go way away from the board. Okay. So the radius is decreasing at a rate of 2 inches per second, so that's dr dt equals negative 2 inches per second because it's decreasing, while its height is increasing at a rate of 5 inches per second. So we have dh dt equals 5 inches per second. And in our picture, if we wanted to draw it in, of course the radius would just be here on the bottom and the height would be this on the side. And then we're trying to find how fast the volume is changing at a certain moment. So we want to know dv dt equals question mark when r equals 4 and h equals 6. So they gave us both of those. In the next problem, which we'll do in class, we have too many variables and we can't get rid of them and we don't know enough information, so we'll get rid of one of those variables, but here we're good. So I'm going to do it underneath this stuff. I'll do my equation. So we already know the equation. Volume equals pi r squared h. And so we just need to do the derivative and then start plugging stuff in. And it's the derivative with respect to time. So we have dv dt equals. Now you can either keep the pi with it first or pull it out in front. I'm just going to keep it right here. So that's going to be first times derivative of the second, because it's with respect to time, plus second times the derivative of the first. And don't forget your dHdt's and your drDt's, because we're doing the derivative over time, and none of those variables are time. So now what we're going to do is just substitute. This time dv dt is the thing on the left, so luckily that's not so bad. And then I'm just going to substitute for everything. So I have pi times, instead of the radius, I'm going to use 4. So 4 squared is 16 times dh dt, which is 5, plus h, 6 times 2 pi times the radius, which is 4, times drdt, which is -2. And so now that's just a whole bunch of arithmetic. It's not so bad because they both have pi in them, so I just need to do, it's going to be 80 pi minus 96 pi. So we're going to get -16 pi inches cubed per second. And always make sure if you get a negative answer, does that make sense? So let's go back and read the question. Or even if I get any answer, always double check my signs. So here we have the radius decreasing and the height is increasing. How fast is the volume changing? Well, it's going to get smaller volume because you're getting tall and skinny, but you're getting more narrow. So a negative volume kind of makes sense. I mean, a negative rate of change of volume, not a negative volume, but the rate of change of volume being negative does make sense. Okay? So that's how we do those problems. So you can work on some of those. We'll finish that one next time so that it gives us one problem to review with.